Hello everyone, welcome to the solution of LeetCode problem 1631 named Path with Minimum Effort. In this problem, you are a hiker preparing for an upcoming hike. Now, you are given heights, which is a two-dimensional array of size row into column, where each of the element represents the height of the cell. Now, you are situated in the top left cell, which is 0, 0. And you hope to travel the bottom right cell, which is row -1 and column -1. Now, there are four possible moves. Either you can move up, down, left, or right. Now, you wish to find a route that requires the minimum effort. So, what basically this minimum effort means? Here, a route's minimum effort is the maximum absolute difference in heights between two consecutive cells of the route. Now let's consider the first example. It is a 3 by 3 grid, which is 1, 2, 2, 3, 8, 2, 5, 3, and 5. Now, if we reach this last cell 5 from this cell 1, we can follow this path, which is 1, 3, 5, 3, and 5. So if we follow this path, the maximum absolute differences is 2, which is the difference between 3 and 5. So we can say that this path is the optimal and the maximum absolute difference is 2. So we have to return 2. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, to understand the algorithm, we have taken the same example. Now, the first intuition comes into our mind is that suppose from any cell, we can go into the 4 direction. Either I can go up, down, left, or right. Again, suppose I go right, and from this cell, I can again go up, down, left, and right, and so on. So basically, you can visualize this problem as one of the traditional graph problem. So now the question is, in which graph algorithm should we use? As we have to find the minimum effort, so we have to use the Dijkstra algorithm. Now let's see how we can solve this problem by using Dijkstra. Initially, we have to build the graph here. So here, for each of the cell, I am giving this a name, which is A, B, C, D, E, F, G, H, and I. So from the cell 1, I can reach 2 and 3. So we can say that from the cell A, by using effort 1, I can reach cell B, and by using similarly effort 1, I can reach cell D. Now, these two is done. So suppose from this cell 2, I can reach cell C, E, and cell A again. So here, from 2, I can reach, or from B, I can reach cell C and cell E. So here the cost is 2. Now, from these 3, I can reach 8 and 5. That means E and G. So, from this D, by using cost 3, we can reach cell E. And from this D, by using cost 3, we can reach cell G. So far, so good. Now, from this C, we can reach to the cell 2 again. So here, from C, we can reach F by the cost of 2. Now, from this 8, we can reach 2 and 3 again. So from this E, we can reach F by using cost 8, and we can reach H again by using the cost 8. Now from this 5, we can reach 3. So we can reach G2H by using the cost 5. Now, for these 3, we can reach 5, and from these 2, we can also reach 5. So we can reach I from G and H. So from F, the cost is 2, and from H, the cost is 3. Now, our graph is built. So if you visualize this graph, you can see that it is a weighted bidirectional graph. And now, if you simply use the Dijkstra algorithm, you can find that this path contains the minimum effort. So where in this path, the efforts are 1, 3, 5, and 3. So the difference between the adjacents of them will be 2, 2, and 2. So here the maximum of all of them is 2. So we can say that for this problem, if we use the Dijkstra algorithm, the maximum difference or maximum absolute difference we can get is 2. Now, to implement the Dijkstra, you can use the priority queue, and the basic principle of the Dijkstra will remain same. Now here, one thing, as we have named these cells A, B, C, D, E, F, and so on, I can simply do it by using the number of row multiplied by 100 plus number of column. I hope you understood the algorithm. Now let's move on to the code. Here, we are given a function named minimum effort, and we are given a 2-dimensional array. Now we are calculating the dimensions. This is the 4-directional vector. Now we are taking a 2-dimensional array effort initialized to its integer maximum, and we are taking a min heap. It will store the pair as the key value manner. Now we are initially inserting the value 0 with the effort 0. Now, while the queue is not empty, we are getting the top element of the queue and storing them into a variable current. So here, as each cell basically is row into 100 plus column. So if we want to find the first coordinate, we have to divide this value by 100. And if we want to find the second coordinate, which is y, we have to perform modulus operation with 100. Now we will remove it from the queue. And if the current cell is the bottom right corner, we have to return its effort. Otherwise, if the current effort is greater than or equal to the effort presented into the 2-dimensional array, we have to simply continue because we will simply skip this path. Otherwise, we have to assign the present effort to the effort, and we have to iterate this loop and try to traverse into 4 of its direction. Now, we have to calculate the newly coordinate x and y, and if the new coordinates becomes out of bound, we have to simply continue. Otherwise, we have to calculate the new effort, which is the maximum of parent effort and absolute difference of the parent's value and the child's value. And we have to insert the new effort with the coordinate value. That means new x into 100 plus new y. Finally, if we did not able to return anything, we have to return -1. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.